Hey guys, so I am teaching virtually today because I am on a field trip. So our date of this lesson will be the 7th. So today is going to be a mixture of some review and then some current things that we'll be doing. So hopefully it's going to be okay for you guys to be able to stay with this and be able to do this without me being here. So our warm-up is asking us to find the exact value. So I need to draw 135. So in this case, I'm going to go past 90, 45 degrees. And when I do that, I draw a 45, 45, 90 triangle. And as I do that, I need to draw my special right triangle. And remember, our 45, 45, 90, it goes 1, 1, square root of 2. But now since we went negative to the left, this is a negative 1, up would be a positive 1, and then square root of 2. Now I want cosine, which is ka, and the angle we're talking about is like right here. So this is the angle we're looking at. So the adjacent over the hypotenuse would be negative 1 is my adjacent, my hypotenuse is the square root of 2. Now we want to simplify that. So remember, to get rid of that square root in the denominator, we're going to multiply the top and bottom by the square root of 2. And so the top becomes the negative square root of 2, the bottom just becomes square root of 2. And so again, it's saying to do this without a calculator, because obviously your calculator would do this for you. So part of our test this chapter will be like no calculator based. So now a negative 220. So negative is going to go around clockwise. So this is negative 180. Or sorry, I don't know what I said, 210. So past 180, 30 degrees. So this is 180, so this would be 210. So this would be a 30-degree angle there. Now in my 30-degree angle, and I always try to draw this kind of so it's obvious where the shorter side is. So in this case, this is my short side. There's my 1, this is 2, and square root of 3. But again, since I went left, that's a negative square root of 3. Now, so I'm going to do opposite over adjacent, or opposite over hypotenuse, so this would just be 1/2. And I'm okay with you guys right now checking this on your calculator just to kind of, as you're doing these and making sure they make sense. Our next one is tangent of 240. No, you're good. I'm just teaching my sub-lesson for Friday.
Oh.
Mr. Hatfield came in and wondered why I was talking to no one. So 240. So 180 is here. I'm going past 180, 60 degrees. So again, now this is a 30, 60, 90. But so our reference angle is our 60-degree angle. So now in this case, again, my 1 is here, it's left, so negative 1. My hypotenuse is here, hypotenuse is always positive, and then down. So in terms of tangent at 240, we're going to do TOA, opposite over adjacent. So a negative square root of 3 over negative 1 will just be a positive square root of 3. And feel free to pause as needed as you guys are taking these notes. Our next one is our quadrantal angles. And this is something we didn't touch on last time. This is when we're drawing these triangles and we're drawing the angles and we end up on an axis. So so the point ends up on an axis. And one of the things that's important to be aware of is when we list coordinate points, cosine sine is the way the coordinates points are listed. So cosine is our x and sine is our y. And then our tangent is our sine over our cosine. And this is all going to make a little more sense once we actually see this on the graph. So when I'm talking about drawing my different types of angles, so my first one would be like a 0 degree angle. It's right here. That coordinate point is right here, and I'm using the unit circle to help me with that. So I'm going to make that point 1, 0. So if I went over 1 and then not up or down at all. If I did a 90 degree angle, that's straight up. So this is 90 degrees. It would be here. That point is 0, 1. If I went all the way around here, that's my 180 degree angle. This point would be negative 1, 0. And then we can go all the way over to 270. This point would be 0, negative 1. Now, if we went all the way around, this is also 360. So just that you know, and then this all repeats. So if we were spinning these angles around further. So now what we're going to talk about is what that means for each of these. So if I'm talking about the cosine of 0 degrees, the cosine is my x coordinate. So in this case, I just look at cosine of 0, my x is just 1. Same thing for my sine. We look at sine of 0 degrees, and I look at the sine value, that's our y, that's just going to be 0. And if you check that, like if you check it in your calculator, even though I want you to be able to do this out of your calculator, it would show you that as well. Now the tangent's the weird one. So if we're doing the tangent of 0, the tangent equals the y over the x, or the sine over the cosine. So this would be 0 over 1, and 0 divided by 1 is just 0. So if you check tangent of 0, it's just going to be 0. So kind of showing you guys that. So like if I asked you for the sine of 90, on my sine of 90 here, again, doesn't want to extend. R. I don't know. Okay, we'll just have to, hopefully you can see the bottom of the screen there. So sine of 90, 90 is straight up. This would be 90 degrees. So that coordinate point is 0, 1. And remember, it's always cosine, comma, sine. So the sine is just the 1. So if you check sine of 90, we talked about that one a little bit before, that should just be 1. Now cosine of 270 is down here. So this coordinate point would be 0, negative 1. And again, if you need the ones up here to help you with that, that's fine. So 0, negative 1. So again, it goes cosine then sine. So cosine in this case would be 0. The next one we're going to do is tangent of 180. So that's over here. So that's 1, negative 1, 0. And its tangent is sine over cosine. So this is 0 over negative 1, so that'll just be 0 as well. And then finally, sine of negative 360. We're going to go negative, so we're going all the way back around. So this just becomes 0 again, that's 0.0 or 1, 0. So sine of negative 360 would be 0. Now I do want to talk about, let's do tangent of this one here. So tangent of 270. Because sine over cosine, this would be negative 1 over 0. When you divide by 0, we're going to say that's undefined. So being aware that the tangent is either going to be 0 or undefined. Sine is going to be 0, -1, 0. So there's like only so many options, but undefined is one that shows up with tangent. So that's our new thing for today. The rest of what I'm going to do up here is just review. So kind of go through some review problems if this would let me. So the rest of this is review. So finding the reference angle for each of these. So 150, so here's 90. I take 90 away. I still need to go 60 more, so I'm going to go 60 degrees more, which is really close to getting to 180. So I'm going to draw that, and again, here's 180. And you can even say how much difference between here, so that means that's a 30-degree reference angle. So our reference angle in this case is 30 degrees. Remember, we always go back to the x-axis, which is this axis. Our next one's 315. So I go 270. I'm left with 45 left. So I'm going to go the halfway. And so there's our triangle. And so this is 45 because here's 360. So 315, the difference between those is 45 degrees. -120. So -90 would be here. So I need to go past 90. 30 degrees. So again, I'm drawing a 30-degree angle. Now, here's 180, so the difference between these two is 60. So that's our reference angle. So being able to find that reference angle is really, really important. So it's probably something I should have reviewed maybe as our warm-up question, but it's going to be in our homework as well. So again, finding the exact value is kind of similar to what we just did in the warm-up, I guess. Kind of redundant, sorry. So cosine of 300. So 300, so we're at 270, we're going past 270, 30 degrees. So this is a 60-degree reference angle. So then this goes 1, this goes down, so this is a negative square root of 3, this is 2. So my cosine is ca, so we're going to go adjacent over hypotenuse. Our next one is hopefully one of the easier ones. So if we have a 60-degree angle here, just a normal triangle, we have our 1, our square root of 3, and our 2. And so is opposite over hypotenuse. So square root of 3 over 2. Our next one is tangent of -150. So I'm going -90. I have to go past 90, almost to 180. So here's 150, 180. That means between them it's a 30-degree angle. And now again, so here's our short side, but it's going to be down, so it's negative. We're going left, so that's a negative as well. Then remember, hypotenuse is always positive. So TOA is opposite over adjacent. And then again, we have to multiply the top and bottom by the square root of 3. The two negatives are actually going to cancel, so it'll be a positive square root of 3 over 3. And then the last thing is our last review problem here, finding the exact values. So it said if sine of A equals 3/4. So what I'm going to do is I'm going to draw my triangle. So sine is so this is opposite over hypotenuse. So I'm going to kind of just draw this kind of nondescript here. So here's my angle. My opposite is here, my hypotenuse is here. I need to find this third side. I move that 9 over, so I get 7. So x is the square root of 7. So what we need to do now is we know sine already. We're going to do cosine, tangent, and then we have to do cosecant, secant, and then cotangent. So cosecant's easy, we just flip it over. Cosine, I have to do adjacent over hypotenuse, so that's going to be square root of 7 over 4. Now the secant, I'm going to flip that over, so that's 4 over the square root of 7, but remember we can't leave it that way. So we're going to have to multiply the top and bottom by the square root of 7. So there's our secant. Then for our tangent, we do opposite over adjacent. And again, can't leave it that way. So this one's a little bit crazier. End up with 3 square roots of 7 over 7. And then again here, I'm going to go back and flip this one. So remember, those are just reciprocals of one another. So your homework is a mix of review and just that little bit of new stuff with those quadrantal angles. So that new thing we learned today was about the angles that land right on the axis. Bring any questions you guys have on Tuesday or send me a message if needed. Hope all goes well. I possibly will be hopping at the end of the hour to help you guys out.